So this is problem number 5 here, and it states that graph y is equal to cosine of x. And again, our domain is restricted in this interval here, so negative 2 pi is again being the lowest possible value, and 2 pi is the greatest possible value that we're looking at. So when we graph this function here, so again for this trigonometric function, we have our x-axis here, y-axis here. Again, so here we, again, with the same technique as I said, you always want to split 2 pi into 4 intervals, right? So this is 0, this is pi over 2, this is pi, 3 pi over 2, and then 2 pi, right? So just do that. And then for 0, again, if you just recall from the unit circle, at 0, so at the point 0, right? At this point over here, when again our angle, you could say, is really theta, right? All of these angles are obviously in terms of radians, but again, to conceptualize the picture, I could have said that pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees, so obviously 0 here is 0 degrees, right? And so when we are talking about 0 degrees, and we know that cosine of a particular angle is really the x-coordinate of any point on the circle, right, of the unit circle. So here on the unit circle, this point here, which is obviously at 0 radians or 0 degrees, your x value here is 1, right? It's 1 comma 0. So that 1 over here indicates that at 0 we have a point over here. Again, when it was sine at 0, it was just 0 because that was referring to the y coordinate here. So we have 1 over here. Now when we put pi over 2, we see that there's 0 at that point. At pi, well, there would be negative 1. At 3 pi over 2, we see that we get 0 back again. And again, if we look at 3 pi over 2, that's a point over here. So we're looking at 3 pi over 2, and for 3 pi over 2, the x-coordinate here is just 0, right? And for sine, it would be negative 1, right? Because we have 0 comma negative 1 there. But so cosine of 3 pi over 2, or cosine of 270 degrees, that's just 0. And then for 2 pi, again, it's the same thing as cosine of 0, that is 1. So this is our graph, right? It looks something like this V shape over here. So graph it, it looks something like that. Again, you don't want to extend it because we're only looking at looking up to 2 pi. And now comes this stuff over here, negative pi over 2, negative pi, negative 3 pi over 2, and then we have negative 2 pi, right? This is what we're looking at. And so again, like I said earlier, or in my previous lesson, a good formula that you want to know in mind is that sine of a negative angle is equal to negative sine of x, right? Similarly for cosine, cosine of negative x is equal to cosine of x. Now this is a different formula, right? And it makes sense, right? Because if you conceptualize this as well, take cosine of any value, right? Take cosine of pi over 4, pi over 4. Now take cosine of negative pi over 4. If you recall, negative pi over 4 is really pi over 4. However, instead of moving in this direction, right? Instead of moving in this direction, we're going to be going clockwise. We will be going primarily first in quadrant 4. And so if we were to go pi over 4 here, right, clockwise, it would be something here. It would be something here. But it's in quadrant 4. And if you recall, all students take calculus. Well, clearly all and calculus, right? These quadrants 4 and 4 is where cosine of a particular angle will always be positive. Therefore, you see that cosine of negative x is equal to cosine of x. However, sine of negative x is negative sine of x, because you know that in the fourth quadrant, taking the sine of an angle will not be positive, right? It will be negative when you take sine of a particular angle in the fourth quadrant. However, for cosine, taking the cosine of a particular angle in the fourth quadrant does give you a positive value. So these are the two formulas you want to know, right? And same thing for tangent. If you have tangent of negative x, if you encounter tangent, that is also equal to negative tangent of x. Same concept as sine. So those are the formulas. Now looking at this, that makes it really easier because we're seeing that cosine of pi over 2 must be the same thing as cosine of negative pi over 2. Well, that means we must have a value here. Similarly for pi, or for pi we had a value here. So for negative pi we must have a value here. For 3 pi over 2 we had a value here. So for negative 3 pi over 2 we must have a value here. 2 pi was here, negative 2 pi it should be here. And so when we graph this, we get something like that. Right, so that's your picture here, or for your graph, and again our x is restricted here from negative 2 pi all the way to 2 pi. So that's the graph here, and again we can talk about our x-intercepts, so I don't have to write them down, you probably get the idea. It would be, here we are talking about pi over 2 comma 0, 3 pi over 2 comma 0, negative pi over 2 comma 0, as well as negative 3 pi over 2 comma 0, and our y-intercept is really again 0 comma 1, right, because that's where it's crossing your y-axis at this specific point. And our domain here is, again, it's just restricted within this one because it's already given to us, and the range is the same as it was for y is equal to sine of x, because it would just be, it's a set of all real numbers such that y is greater than or equal to negative 1, or being less than or equal to positive 1. Again, as negative 1 and positive 1 are really the lowest and the high, or the lowest and the highest points respectively, right? In your graph, you can have negative 1 as being the smallest value and positive 1 being as the largest value. But if you understand these three formulas, right, sine of negative x is equal to negative sine of x, cosine of negative x is equal to cosine of x, and tangent of negative x is equal to negative tangent of x, you should be able to graph these trigonometric functions with ease. So thanks for watching.